Hey, yeah, good morning, everybody, and once again, welcome to Pankaj's Echelon Tutorials. In this today's session, we are going to solve another question on electricity for IGCSE Physics 10th grade. And this particular question number 8, I have taken from 2020, uh, 2020 February, March. Okay, this is February, March paper 2020, and this is paper 42. Okay, so from this particular paper I have taken this question number 8, and question number 8 says that in figure 8.1 there's a circuit shown over here, right? So what you have to do is uh, let us see the circuit over here, and you have to calculate the reading of the ammeter. Okay, so this reading you have to calculate what is the reading on the ammeter. Of course, the reading on the ammeter will be the current flowing through the circuit. Okay, so basically you have to find out the current flowing through the circuit, isn't it? Now, as you can see, the voltage, the supply voltage here is 12 volt, and you can see there's a 3 ohm resistance over here, there's a 2 ohm resistance over here, and this XY wire has a uniform resistance of another 6 ohms, right? So in fact there are three resistances, 3 ohm, 2 ohm, and another 6 ohm. All these three are connected in series. Okay, so I can write that R equivalent of the circuit is equal to 3 plus 2 plus 6. That works out to 3 plus 2 is 5, 5 plus 6 is 11 ohms, right? So the total resistance or the equivalent resistance of the circuit is 11 ohms. Now the voltage, the supply voltage is 12 volt. Now we know that V is equal to IR. So I we want to find out, I will be equal to V upon R. Now this R will be nothing but R equivalent, and V will be the supplied voltage, that is 12. So 12 divided by this R equivalent, which is 11, this will give you the value of the current coming out from the supply. Okay, so 12 upon 11 will be the answer, and that will be in amperes. And 12 upon 11 should work out to, let me check, it should be 12 divided by 11, and it's a 1.09 ampere. The answer is 1.09 ampere. So calculate the reading on the ammeter. So the ammeter reading should be 1.09. 1.09. Now let us move on to subquestion B. Subquestion B says that figure 8.2. Now you can see this another figure 8.2. It shows the circuit with a different connection to the resistance wire and an added resistor. The length XY of the wire resistance and the length XY of the whole resistance wire is 2 meter. Okay, so the contact is made at Q, where the distance XQ is 0.6 meter. Okay, now this is a circuit diagram in which he says that it's a similar circuit that was shown in the A part of the question, with this 3 ohm and this 2 ohm resistance. Okay, let me check, it was 3 and 2. Yeah, 3 and 2 was already there, but then this one more 1.5 extra resistor has been added to the circuit, and this XY, which was 6 ohms, now this 6 ohm was for 2 meter. Now the point Q has been chosen, and XQ length is 0.6 meter, 0.60 meter. You have to calculate the resistance of the circuit. So basically you have to calculate the equivalent resistance of the circuit. Okay, now equivalent resistance of the circuit, if you want to find out, then just think of the current coming this way. Okay, I have already marked this arrow mark, so this is the current. It will come here, and here at this stage it will get divided into two, that is I1 and I2. So at this point you can see this 1.5 ohms, and whatever resistance will be for this XQ, these two are connected in parallel. Now let us first find out what will be the resistance of this XQ. Okay, So we know that resistance is directly proportional to length. Okay, and so we are going to use this. So resistance for xy is how much? Resistance for xy is equal to 6 ohm. That is given in the A part of the question, or even here it is given. Okay, uh, no, here it is not given. So for xy, the resistance is 6 ohms. So what will be the resistance for xq? This is the thing that you have to find out. So 6 ohms is the resistance for length equivalent to 2 meter. What will be the resistance, okay, when the length is 0 0.6, that is for xq, isn't it? Xq length is 0 0.60 meter. So 0 0.60 meter. Okay. So here the answer will be 6 times 0 0.60 divided by 2. Now here I want to caution the students, okay? Okay. Some students, because they may think that this is a very straightforward, simple calculation. I may not need any calculator, and he may not use any calculator. And the answer that he may land up to is 6 threes are 18, and then he'll put a decimal point after two places, 1 2. So he'll end up with this answer, which is totally a wrong answer. In fact, it's a blunder. Okay, so don't do this way. Actually, what you have to do is 0.60. In this 0.60, this the what you can say, the last zero, or the trailing zero. Okay, the trailing zero is not considered. Okay, so don't consider this as 0.60, consider this as 0.6. Now if you work out, this will be 0.3 into 0.6, which will give you the answer as 1.8 and not 0. This is the correct answer. So if you do it, even in on the calculator, if you do it, you will, even if you type 0.60 into 3, the answer that the calculator will show you is 1.8 only. Okay, because the calculator is not going to consider this trailing zero of 0.60. So this is for your caution that I am telling you. This will be a blunder. This will give you a wrong answer, and this is the correct answer. Okay. So the resistance of this RQ, we have found out, the resistance of this XQ part will be 1.8 ohms. Okay. So this is 1.8 ohms, right? Now, the job is not over. We have just found out this resistance. So this resistance I have written here 1.8 ohms. Now what will happen? Now, see, current is entering at this point, and it is getting distributed into two parts, I1 and I2 over here. So these two resistances, this is 1.5 and the one which we have just find out, that is 1.8. They are in parallel. Okay, because the current is getting distributed between the two resistances, 1.5 and 0. And 1.8. Between these two, it is getting divided. So therefore, the two resistances are in parallel. So equivalent of this, R equivalent, will be equal to 1 upon 1.5 plus 1 upon 1.8. Now this should work out to, and now I'm going to use Calci. Okay, so 1 divided by 1.5 should work out to, now I'm getting in a fraction over here, so not a issue. I'll write this 2.2 by 3, and 1 divided by 1.8 I'm getting as a fraction, which is 5 by 9. Okay, 5. So let us work out this. This will be how much now? 9 and 3, so LCM will be 9. So 3 into 3 is 9. So 3 2s are 6. This is 9 into 1 is 9. So 5 ones are 5. Okay, so this works out to 11 upon 9. So this means that R equivalent will be equal to 9 upon 11, isn't it? Which will be equal to 9 divided by 11 should be equal to uh, 0.82. Okay, 0.82 ohms. So this 0.82 ohms is the equivalent of these two resistances, 1.5 and 1.8. Okay. Now we are supposed to find out the calculate the resistance of the circuit, that is the RT. So RT will be equal to this 2 ka equivalent we have found out, which is 0.82, plus now there are two more resistances, 3 and 2, which will add up to 5, and this will be in series with this. So 0.82 plus 5, this should be the answer. So the total will be 5.82 ohms. This is the total resistance of this circuit. So the answer is 5.82 ohms. Okay. So with that, we end up one more interesting question on electricity from physics IGCSE, and this was picked up from the paper February March 2020, paper 42. Okay, so that's all for today's session, and meet you in the next session with some more interesting questions. Till then, goodbye, take care all of you, and if you happen to like my video, please do subscribe to my channel. Bye, take care all of you.